Hello info person, this is Anton, and today we're going to discuss a fascinating discovery that once again suggests that the solar system is not as isolated as we believed. Or essentially, the solar system may be affected by many different stellar flybys and many different stellar visitors that sometimes trigger massive cosmic events, as the region referred to as the Oort cloud gets disturbed and basically sends a lot of different cometary objects toward various planets. And specifically, we're going to discuss this extremely recent study, the study by Nathan Cabe and Sean Raymond, that once again discovers a potential stellar flyby that very likely happened 2.5 million years ago, but may still be influencing the solar system even today. And so let's talk about this in a bit more detail, but first let's start with some basics, just so that there's no misunderstanding. And actually let's start with this picture of the famous Scholt'z star. The object we've discussed previously, that's essentially a dim binary stellar system approximately 22 light years away from the Sun. And while not so long ago, specifically in 2013, the astronomer Ralph Dieter Scholt'z discovered that apparently this star actually passed extremely close to the solar system approximately 70,000 years ago. Or basically, by tracking its trajectory, he discovered that it potentially passed within the solar system's Oort cloud, or approximately 50,000 astronomical units away from the Sun. And while we don't really know exactly what this did, but it's quite likely that at least some of the objects in the Oort cloud changed their orbits, and some of them might be headed our way. But because this only happened 70,000 years ago, and because it takes much longer for an object to travel from the Oort cloud to the inner solar system, we're actually not going to know the results of this for possibly at least 1 million years. In other words, it will take at least 1 million years for some of the first objects to come close to planet Earth or other planets. And though previously we've assumed that these types of flybys or these types of events might not be that common, or basically that the Sun and its planets represent a kind of a permanent, unchanging neighborhood, today we know the galaxy is a very busy place, and stars are constantly moving and coming close to each other, resulting in these stellar flybys. And technically we've seen this many times in other star systems, where passing stars actually disturb the formation of various dusty disks, with one famous example being right here, the star known as UX Tauri A. And so essentially this is not as uncommon as we previously thought. And while based on these initial observations and essentially the statistical analysis of how likely this is to happen to the solar system, today researchers estimate that we potentially experienced around 12,000 such encounters, with a star approaching the Sun within approximately 1.5 light years. Enough to essentially disturb some of the Oort cloud objects. But naturally, the closer the star gets, the more disturbance it's going to create. And well, when it comes to the Scholt'z star, it wasn't too close and it wasn't too far, so its effects are potentially going to be minimal. Although here, as a side note, let's actually briefly discuss the Oort cloud, just so that we're clear what's happening in there as well. Because to understand these flybys, we do have to take a look at this region. And well, in essence, this is a massive sphere-like formation containing billions, if not trillions of icy objects that surround the solar system. And while all of them are extremely far away, far beyond the orbit of Pluto. This is essentially where all of the long-period comets tend to come from. Comets that take thousands or even millions of years to reach the Sun. And normally, the gravity of the Milky Way galaxy, what we usually refer to as the galactic tide, gently nudges some of these icy bodies and sometimes sends some of them toward us. In other words, even without any kind of a passage or a flyby, at least some of them will always come close to the Sun just because of the galactic interactions. But in this recent study, researchers uncovered something that they did not expect. Here, Nathan Cabe and Sean Raymond discovered something when looking at dynamically new comets, or essentially comets visiting the inner solar system for the first time ever. Comets that did not become periodic yet, and that have never experienced solar radiation before. And here their orbits don't follow the pattern expected from the Milky Way's gravity or from the interaction with the galactic tides. Instead, they actually appear isotropic, meaning that they're coming from pretty much all directions, more or less equally. And that means that they were not disturbed by the Milky Way tides and were disturbed by something else relatively recently. In other words, based on the observations from comets coming from all directions, researchers suggest that something else must have jostled them, causing them to suddenly change their orbits and basically approach the Sun, which essentially led them on a quest to find if any other star approached the Sun in the last few millions of years. And luckily for them, we now have a perfect catalog to look for all of this, the Gaia Telescope catalog. The catalog that contains the motion of millions and millions of stars, and that essentially allows us to rewind time and find out where these stars used to be. And so that's essentially what they did. They looked at the motion of billions of stars by winding back the clock. And here they found one object, a somewhat less known star referred to as HD 7977. A Sun-like star, or a G-type star, that's currently 246 light-years away from planet Earth. And based on the Gaia analysis, we now are pretty certain that the star passed within about 4 to maybe 25,000 astronomical units away from the Sun, anywhere from 2.5 to 2.8 million years ago. In other words, it was even closer than the Scholt'z star, and definitely had a lot more effects because it is essentially a Sun-like object, way more massive than the Scholt'z star. And that means that the star definitely passed right through the Oort cloud, around the time of our ancestor Homo erectus learning to dominate the planet. As a matter of fact, at some point in the past, this star might have been so bright that it would most likely represent the brightest object in the night skies except for the full moon. In terms of luminosity, it would be much brighter than Venus and resemble the brightness of a new moon when it's just a crescent, with luminosity produced by this object potentially being bright enough to actually see just enough in the dark, or to even read a book or something. Not that books existed back then. But yeah, when it comes to, for example, hunting at night, it potentially made things much easier for animals whose eyes were not as developed. And so if this is all correct, the encounter here would have been extremely powerful. This would have been one of the strongest stellar flybys in the last billion years. With this particular passage, scattering comets in every single direction, and basically causing a lot of those comets to approach the inner solar system, and maybe some of them even collide with certain objects. As a matter of fact, the most intriguing part is that we are now possibly still living through a kind of a leftover or a tail of this unusual cometary shower event, mostly because the Oort cloud is extremely large, and it does take millions of years for some of these objects to finally reach the inner solar system. And the simulations from the study suggest that the overall number of visiting comets potentially increased by at least 10 times compared to what we usually expect from galactic tides. Or at least that's what it used to be like around a million years ago. But even today, we're seeing at least twice as many comets as was expected from the galactic tide interaction, with researchers suggesting that it potentially will take 5 to maybe even 10 million years before the number returns to its normal value. And well, by itself, this is a pretty important discovery, mostly because it suggests that we might have actually overestimated certain things. For example, when it comes to the Oort cloud itself, we might be seeing twice as many comets right now, which means that the actual number of objects here is not as high. Or just to rephrase this, the number of objects in the Oort cloud and the overall mass of the Oort cloud might have been overestimated. Second, this also reminds us that we're technically at the mercy of nature's whims. Or basically, while these flybys can certainly be quite dangerous and obviously increase the risk of comets, based on the observations from the last few millions of years, we also know that they certainly do not cause any major extinction events and do not cause major collisions like the one that wiped out the dinosaurs. Except for birds, because birds are dinosaurs. But at the same time, there's also this intriguing possibility of one day, either for us or maybe some other civilization out there, to basically hitchhike or star hop by waiting for one of these flybys and then basically jumping ships and trying to land on some other planet that's now actually reachable using modern technology. In other words, some scientists actually speculate that humanity in the future or some other civilization out there could actually use these flybys as a stepping stone to travel across the galaxy using minimal energy. And since the star that passed in this case is extremely similar to our Sun, or essentially it's one of the other G-type stars that most likely contains at least some planets resembling what we have in a solar system, at least in theory, it might be possible for someone out there to one day hitch a ride during these flybys. Although based on what we know about this star so far, we don't really know if it has any planets. But as we've discussed in some of the previous videos, this is obviously not the only visitor that we know of, and more importantly, not the only star that's going to be approaching the solar system in the future. Because looking ahead, we know that at least one star, Gliese 710, is going to be doing exactly the same in approximately 1.3 million years, and it potentially will come even closer. 0.16 light years, or approximately 10,000 astronomical units away. And at that distance, it will be also just as bright as HD 7977 and will once again make the night skies much brighter, while once again potentially triggering a new cometary shower that's going to start in approximately 2 to 3 million years from today. But at the same time, if future humans are still around and potentially have become good enough for at least basic interstellar travel, it might give us a chance to hitch a ride on one of the planets from the star system and thus become interstellar for real. And well, because this is a K-type star, it means that it's also going to survive much longer than the Sun, and if it contains any planets close to the habitable zone, they'll most likely remain habitable for billions of years longer than Earth. Although once again, we have no idea if this has any planets, but chances are that it does. But I guess in conclusion, well, it looks like some of the comets we see today are kind of anomalous, in a sense that they represent a cosmic signature left behind by an ancient flyby from a star that's surprisingly super similar to our Sun, technically one of the most Sun-like stars in the vicinity, while also showing us that the history of the solar system is occasionally rewritten by various passages of our neighbors that once in a while cause certain comets to collide with certain planets. But naturally, as we collect more data from telescopes like the Vera Rubin Observatory, and as more Gaia data is analyzed, there is a chance that we might find other stars or other objects that have done something similar in the past, or will do something similar in the future. Or we might even find actual objects coming from the Oort cloud for the first time ever. Objects that were disturbed by the star 2.5 million years ago. But for now, that's pretty much all we know. Once there are some additional discoveries, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.